Hello friends, I myself Dr. Bharat Parab. We are discussing today how to find root x for the any given positive real number x geometrically. We are trying to find out the root x value for any given positive real number. Okay, so we are trying to find out it geometrically. So let us take x equal to 9 units or 9 centimeters for simplicity, which is a perfect square of 3. This is we are taking just for simplicity example, and try to solve it the way we have to solve. Okay, then draw a segment of 9 centimeters. Okay, extend it by 1 centimeter. Remember, you have to extend by only 1 centimeter for any value of x. Okay, now this has a center and this has a diameter. Draw a semicircle over this in this manner. Then drop a perpendicular from semicircle to the segment end which we have drawn, and from this to the center which will act as radius. Okay, now concentrate on the triangle OAB, which is a right angle triangle. Yeah. Now this is 9 centimeter as we have drawn, and this is 1 centimeter extended. So diameter being 10 centimeter, radius will be 5 centimeter. This we are calculating only for simplicity. Okay, taking particular values. Now this is with the 5 centimeter, just to make problem very easy. These are the radius of the same circle, and OA will be 4 centimeter as we have totally drawn 9 centimeters, and minus 5 is 4, and we take AB as Y. Now concentrate on the triangle OAB. By Pythagoras theorem applying to the OAB, okay, we are applying Pythagoras theorem for the triangle OAB, you get y square plus 4 square equal to 5 square, which is a diagonal of the triangle. So we will rearrange y square equal to 5 square minus 4 square. Now don't put these values, use identity instead, which is a square minus b square equal to a plus b, and a minus b, which gives you a simple solution for the problem. So you get y square equal to 5 plus 4 and 5 minus 4. Okay, so see this quantity, 5 minus 4 is 1, 5 plus 4 is 9, and if you see this 5 plus 4, which is two other sides of the triangle, 5 centimeter and 4 centimeter, addition of this, and this is extended part 1 centimeter. So you get the addition of these two, have you seen, and that means this is a addition of the segment which we have drawn. It's 9 centimeter, very interesting. Okay, so here you get y square equal to 9, very very interesting method. Y square equal to 9, so y equal to root 9 or equal to 3. So you see here, see the AB value in triangle AY we have calculated as 3, which is a value same as root of the segment length given, it's 9 centimeter. So we have calculated the root of any given number, in this case it is 9, geometrically, not theoretically, geometrically. Okay, let us go for the another example. Okay, let us take any arbitrary value for x. Say for example x equal to 4.8 units or centimeter. However, the method remains same as in the earlier example. So we take 4.8 centimeter and draw a segment of 4.8 centimeter like this. Extend this segment by 1 centimeter in this way, and with this as diameter, take this as center, and draw a semicircle over this with extended part and this as diameter. Drop a perpendicular from segment to this and join the center with this, so to form triangle OAB. Now this is 4.8 centimeter as we have drawn earlier, and this is the extended part 1 centimeter. So the total is from here to here, it is 5.8 centimeters, which is a diameter of the semicircle. So the radius will be half of it, 2.9 centimeters. Clear? That is very clear. So this is 2.9 centimeters. Okay. So from this is 1.9, 4.8 minus 2.9 is 1.9. This is again 2.9 as is the radii of the same circle. So concentrate on the triangle OAB, where AB is equal to Z. Now in triangle OAB, applying Pythagoras theorem for triangle OAB, we get Z square, see here, Z square plus 1.9 square, it's a right angle triangle, equal to hypotenuse is 2.9 square. So Z square is equal to 2.9 square minus 1.9 square. That is very clear. Now you don't put the values, use identity instead. For this as a square minus b square equal to a plus b and a minus b, that will make your problem very simple. So you get Z square equal to 2.9 plus 1.9, and you see very interesting fact in this, and 2.9 minus 1.9, so this is 4.8 and this is 1. Now around this quantity is like 1, and we will discuss something of this, and this is 4.8. If you see, very interesting example of this is 4.8. See here. So this is the addition of the two other sides of the triangle. This is 2.9 and 1.9. This is radius, so this is addition of 2.9 plus 1.9, which is 4.8. That's segment which we have drawn, and this is 1. The extended segment always comes out to be 1 for any example. Okay. So with this we go ahead, Z equal to a root of 4.8. Is that very clear? Z square is 4.8, so Z equal to root of 4.8. So if we see this here, which is Z is equal to a root of 4.8. So this is the root of original value of x, the segment which you have drawn 4.8 centimeter. So we could draw a segment equivalent to root of any given segment. This is 4.8. So we have drawn a root of 4.8. So we have found out the root of x for any given value of x. In this case it is 4.8 units or 4.8 centimeters. So you have seen. So we generalize the statement. We find root x for any positive real number given x, any value. Okay. So procedure remains same. Draw a segment of length x centimeter. For simplicity we take centimeter as a unit. Extend it by 1 centimeter. Draw this as center and complete this semicircle with extended path and segment drawn as diameter, and drop a perpendicular from semicircle to the segment drawn, and complete this triangle by joining radius and semicircle, and concentrate on the triangle OAB, which is a right angle triangle. Okay. Now if you see, this is x which we have drawn, and this is 1 centimeter extended part also we have drawn. So with this, x and plus 1 is the diameter of the semicircle. Have you seen this? So if this is a diameter, then what will be the radius? Radius will be half of this, x plus 1 divided by 2, of course. This is the radius. So we take this as x plus 1 divided by 2, and this is also radii of the same circle. So this is also x plus 1 divided by 2. Now concentrate on this OA. What is this? This is radius minus 1. If you see, so OA is equal to x plus 1 divided by 2 minus 1. Go for the simple calculations. If you see this, these are very simple calculations, and you get ultimately x minus 1 divided by 2. So this value is equivalent to this. Okay. Now concentrate on the triangle again, OAB. Okay. So in triangle OAB, applying Pythagoras theorem, let us for simplicity we call this as y, AB as y. So we get y square plus x minus 1 divided by 2 square equal to the hypotenuse x plus 1 divided by 2, which is equal to the radius. Got it? Then we rearrange this and get y square equal to, we take left hand side value to the right hand side and subtract it. Now here you use identity a square minus b square as shown in the earlier example, and you ultimately get x plus 1 divided by 2 plus x minus 1 divided by 2, the first quantity, and x plus 1 divided by 2 minus x minus 1 divided by 2. These are very simple calculations, and solve it. We solve the bracket like this, very simple calculations, and x plus 1, so in bracket it will be minus and this will be plus 1 divided by 2. If you cancel 1 here and x here, and ultimately you get y square equal to 2x divided by 2 and 2 divided by 2. Earlier also we got 1 in this, here also we got 2 divided by 2 as 1. So y square is x. So y equal to root x. Have you seen this? So this value of y is root x is equivalent to the root of original segment drawn x. So we have geometrically found the root value of any given segment x. Okay. So for any given segment we could calculate a root x geometrically. So understood? If you have any problem, let me know in the comment box and I shall try to solve it. Okay, thank you.